physics lesson. My name is Nicholas Okuthe. Today we want to look at a topic called electronics. And electronics basically is the study of movement of electrons in electrical devices. Now, the movement of electrons, electrical devices applied in so many electrical devices like radios, TVs, computers, robots, calculators, and so on, even our mobile phones. Now, this movement results in what we call electrical conductivity. And in terms of electrical conductivity, materials are classified into three. So we have three classes of materials. That is, we have conductors, insulators, and semiconductors. Conductors basically are materials that are able to conduct, meaning they have free electrons that can flow freely within the material and conduct. Insulators, materials that cannot conduct electricity, and we'll see why. While semiconductors are materials whose electrical conductivity fall between conductors and insulators, meaning at one point they can be insulators, another point they are conductors. So with that, we want to look at something called the energy band theory. Energy band theory is talking about the behavior of energy levels in an atom. Remember, an atom has what we call an orbit where electrons reside, that is the energy levels. So when two or more electrons are brought close to one another, then their energy levels split further into other energy levels that we call bands. We have two types of bands, that is the conduction band and the valence band. So the space or the region between the two bands, we call them the forbidden energy gap, or simply forbidden gap, or energy gap. Now, conduction band is the region that is occupied by free electrons, while the valence band is occupied by immobile, that is electrons that are not free to move. So the space between them, we call it the forbidden gap. So with the two types of bands and the region between them, we can use them to distinguish between, or to differentiate between the three classes of materials. We start with conductors. Conductors, as we have said, they are able to conduct, and the reason why they are able to conduct, for conductivity to occur, electrons should always be able to flow from the valence band to the conduction band. So conductors normally have energy gap that has the valence band and the conduction band overlapping. From my drawing, you can see that overlapping, meaning electrons can easily flow from the valence band to the conduction band, and that flow results into the flow of electrical current. So meaning in conduction band, or in conductors, we have the valence band and the conduction band overlapping between the energy gap. When we come to insulators, they are not able to conduct, and the reason why they are not able to conduct is because they have a wide energy gap between them. So meaning for electron to flow from valence band to conduction band, they need more energy, and that energy may not be achieved even through heating. So at the end of the day, the wide gap bars the electrons from moving from the valence band to the conduction band, and whenever there is no net movement from the valence band to the conduction band of the electrons, then the conductor or the material will not be conductor, and that's what we refer to as an insulators. So meaning increase in temperature does not affect its electrical conductivity. Dumping or addition of impurity does also not affect its electrical conductivity. It will remain an insulator at any temperature. Finally, we have semiconductors. A semiconductor, what distinguishes from the other two is that it has a narrow energy gap. The gap between the conduction band and the valence band is narrow, meaning electron can flow from the valence band to the conduction band. So that flow, electrons will need energy, and we'll see that for semiconductors at 0 Kelvin, they are insulators because the electrons here do not have energy to flow across the energy gap or the forbidden gap. But when at room temperature, they also behave like insulators, meaning still electrons cannot flow from the energy gap, from the valence band to the conduction band. But when now we heating makes the electron gain energy that's enabled to propel them across the energy gap. So increase in temperature will increase their electrical conductivity, meaning they are good conductors when heated, because heating reduces the resistance and electrons can now flow. Another way of maybe making them become conductors is by doping, that is addition of impurities, as you will see later. One thing maybe I didn't say about conductors, as we learned in the Ohm's law, one of the factors that affect electrical conductivity of a material is temperature. But then for conductors, when we increase the temperature, we increase the vibration of the atoms. And this vibration of the atoms hinders the flow of electrons. Therefore, the flow of the increase in temperature in conductors will normally lead to increased resistance and therefore reduces the electrical conductivity of such a material. So we are seeing temperature affects the conductivity here. By increasing temperature lowers the conductivity, but here increase in temperature increases the conductivity.
3.
So with that, semiconductors are further divided into two. We have two types of semiconductors. We have intrinsic semiconductors and extrinsic semiconductors. Because semiconductors' electrical conductivity can be improved by either raising the temperature or by adding impurities, that is what gives us those two types of semiconductors. When we talk of intrinsic semiconductors are semiconductors whose electrical conductivity can be improved by raising the temperature. You simply heat them, then they become good conductors. Basically, we have only two types of intrinsic semiconductors, that is the silicon and germanium. And extrinsic semiconductors. Extrinsic semiconductors are also conductors whose electrical conductivity can be improved by adding small amount of impurity. You take another atom or element, we add to it. That is what we call impurity. So the process of adding an impurity to a pure semiconductor to improve its electrical conductivity, we call it doping. Process of adding a small amount of impurity to a pure semiconductor to improve its electrical conductivity, we call it doping. So generally, extrinsic semiconductors are sometimes called impure semiconductors. They are impure due to the fact that we add some other impurity, so it makes them impure. So we call them impure semiconductors because we simply add an impurity to it to improve its electrical conductivity. Now, these impurities, we have two kinds of impurities that we use for doping. One of the impurities is called using a pentavalent atom, that is a group 5 atom. Group 5 atoms, when added to an added to a semiconductor, will end up with now what we call a p-type. Then we have using a group 3 element, that is a trivalent atom. And trivalent atoms, the atoms that have 3 elements in the outermost energy level, so that will make these what we call an n-type semiconductors. That is the end of our lesson. Let's meet during the next.